So last Thursday, I purposely had us do an extra day of regular probability because I knew if we started this on Thursday and then finished it today, you very possibly would have forgotten everything in between. And I thought regular probability, not that it was easy, but a lot of you kind of intuitively understood probabilities where it's not something you would forget over the weekend, over a 5-day weekend. So independent and dependent events is what we're going to do today. And it's independent and dependent events is what happens when you start doing probabilities of more than one thing. So simple probabilities is kind of what 11.2 focused on. Kind of, because I know there were some questions that weren't set up as simple. Probability of rolling a 2 on a dice. You had to look for desired outcomes on the top. On the bottom was number of possible outcomes. And so it was one side out of 6 sides, and so that was the probability. So a lot of you kind of just got those, you knew those just because there's something you've done over the years. So independent and dependent is what specifically happens when you're doing more than one event. Where's my mouse? There it goes. So there are 2 formulas for this. I do have them on the front whiteboard if you need them to. The part that I want to highlight and emphasize is they both represent the word and. Because we are going to get to the stage where when you're given a probability, it's going to be one of 3 things. Simple probability, which is one event. An and statement, which is today. Or an or statement, which will be tomorrow. Those are the different kind of situations that can happen when you're doing probabilities, and you do different things with the numbers. And so that's why it's going to be key that you know which situation you're dealing with. And it's usually pretty straightforward because they traditionally just literally use the word and or in the sentence. And we kind of already did some of these, to be honest. I think that was Thursday when I started re-explaining some of the topics, like the balloon problem. I don't know if you semi-remember the balloon problem. I taught you how to do it with simple probability, which was kind of just like counting up things, and using combinations and stuff like that. But that balloon problem was technically a dependent event. Because when you pulled one balloon out, it changed the probabilities for future balloons. And so each pull of a balloon was dependent upon what you pulled out beforehand. So like the green ones, if I remember right, I think there were 3 green balloons out of 12 total. So the probability of pulling the first green balloon was 3 out of 12. But then once you've pulled a green balloon out and you don't put it back in, there's now only 11 balloons in the bag, and only 2 of them are green. So then your second probability of green is different from the first time. So that's considered dependent because things change as you do the problem. If that problem had been set up different, Jack, not now. Sitting in the back was not a good choice for you. The problem could have been set up different to be independent. Because if you pull a balloon out, figure out that probability, and then put the balloon back in, so they would consider that with replacement as the wording you're going to see, then that would be independent events because the chances of you pulling a balloon out are going to be the exact same as the first time. Like putting a balloon back in means that the situation was the exact same that it started with. So those are going to be the differences between the two. absolutely, I don't feel like I really even need to say this to you guys. Put your Chromebooks away. I get it if you're pretending to have my notes out and you want to just ignore me and read the notes, but that's going to go badly for you. So, simple probabilities is where a lot of people usually do okay. Once we start getting to conditional probabilities, a lot of people cannot do them in their head, and they start doing much worse if they're not actually like paying attention to things you need to write down. What you should write out of this, and probably want to write a note to yourself. The word "and" means you are going to multiply the probabilities. I mean, it's written in both of those formulas, but you may not put that together on your own. These two formulas are essentially the same thing, to be honest. Both of them, you multiply the probabilities. So whenever you see the word "and" in a statement, you multiply the probabilities. And that may seem super simple right now, but then once we get into the "or" statements, which you do something different, then it kind of starts getting confusing when they're all mixed together. And that's where I want to try to help you separate things. Hadley. Chrome. There we go. Okay, let's do a problem together here. I was very proud of my picture that I created for this. I'm normally not very nice and neat. Clearly, I didn't write the sentence. That was somebody with much better handwriting. This was back when our smart boards actually worked, and students usually took turns writing out the questions. But they're 13 years old now. It's actually really impressive that some of them are still working after 13 years.
Wow,
Most electronics don't last very long, and educational use, it gets used a lot.
They're probably like out of college now. Wonder where they are.
Oh, that is kind of weird. I didn't even think about that. When we first got these, the kindergartners have already graduated. That is strange. So you guys are a generation. You guys are a generation that you've grown up with smartboards. I suppose none of you ever had a chalkboard for a teacher.
I had.
Did you?
I had a chalkboard. I did.
Not in our school district, probably.
No, I was in Iowa and Ohio.
Yeah, I wasn't saying they were bad. I like chalkboards. They're actually.
Because of the fact that babies were born in 2019.
That's not okay.
That's not
There's literally a
okay.
baby being born today.
Yes,
Not okay.
exactly.
I completely missed that. What?
Babies are born in 2019. It's not okay.
Like that shouldn't happen.
Like they're too young. Like imagine like your baby saying and you're like, how old are you? And they're like, oh, I was born in 2019.
Well, they probably can't talk yet.
Well, what if they're like a?
Oh, and I guess they probably could.
Class of 2030.
That's okay. You guys aren't even remotely close to the point where you feel old yet. I'm now hitting the stage where children of the people I first taught are through schools. Yeah, that makes me feel old. Okay, you definitely had enough time to write this one down now, huh? Who should we go? Drew. Let's get you involved. You ready? Okay. Find the probability of spinning a 4 and then a 4 again. Now, do you want me to help you start out by writing it out in terms of like math notation? Could you tell me anything about this? Are these independent, dependent?
Isn't the probability of getting 2 4s in a row just 1 over 64?
Why?
Because you do 1 over 8 and 1 over 8.
Why'd you do that?
There's 3 4s in mine.
Oh, yeah, there's 3 4s. You just saw the 1 and then went with that?
So it would be 1 over 8 cubed.
Cubed?
964.
Mm. Let's start by figuring out. So, I guess this is kind of what I was trying to talk about at the beginning, where simple probability a lot of times you can just kind of like do in your head because it makes sense. And then you start getting to these conditional ones, and it's almost like your brain tries to think about it too much or something. Are these independent or dependent? So what you would try to think, because this one is talking about spinning a spinner. If we spin the thing one time and get an answer, and then spin it a second time, is that second spin going to be affected by whatever we got the first time? That's kind of what you're trying to think about. No, it's not. So every single time you spin this, it could be whatever. Like, the probabilities don't change each time, mainly because none of the choices are being removed. Like, if you spun the red 4 and then you would take that piece out, well, then the second spin would have different probabilities because that's no longer an option. That would be dependent. But on this one, everything is still there. You can still choose anything. And so those would be considered independent. Are you going to ask me because of where the spinner ends up landing?
Oh, no, I
Oh.
was gonna ask if this could be applied to like our past, like what we learned last week. Like, could you just, never mind, I think.
I know what you're trying to say. It is.
Okay.
One tendency I've seen in the past is when a student tries to overthink these, and I get why. The easiest way to overcome that is just by doing examples and understanding how problems are set up. So I could see how somebody could overthink this and say that it does matter where the spinner lands because when you flick it, it only goes so far and that would affect the next number chosen. I've definitely had people in the past bring that up. And I understand that reasoning. We could say something like there could be details written in the problem saying after each spin the hand is reset to the top or something. So in that case, it would make it clearer. But these are supposed to be totally independent of each other. Now, in terms of what you were asking about relating this to section 2 on probabilities, once we figured out these were independent events, we're trying to figure out each probability separately. So what would be the probability of spinning a 4? The number of 4s on here is the desired outcomes, which would be 3. There's 3 times you can get a 4. And the number of total outcomes means what are the possible answers you could get just from spinning. And there were 8 different things. So this is how it relates to simple probability.
Gotcha.
And this is the exact same one, so it's not like we have to redo it. Like the question could have been spinning a 4 and then a 2 or something, and then the answers would be different. But this one is going to end up being 9 over 64. Now, you can write the answers as fractions, decimals, percents, just the same as before. And you are still allowed to use a calculator. So the main thing I don't want you stressing about is the actual numbers. And I know some of you do, but like you have access to resources. The prime goal here is to figure out probability things. Okay, I know I spent a long time on that first question just because I wanted to be clear on what we're doing with it. Any kind of questions about that setup or anything? I don't know. Okay? Why don't you guys try this one on your own? All right. Find the probability of spinning a red and, actually this one should say the word and. Let me rephrase this so that it has the word and in there, even though it's bad grammar. I don't even know how I'm going to fit the word in there.
Well, what's the probability of spinning a red, then green, and then a 1? That would be proper grammar.
Well,
Well, because
it's
it's
kind
comma, and then the last.
it's kind of just a run-on sentence, yeah. So the way it was first written was correct grammar, but makes it harder. Why does that look wrong? Whoa, I drew this whole thing individually?
Woo!
I did not remember that. That's impressive.
Curtis.
Am I coloring with fake crayons too? I mean, that's clearly the best drawing you're going to get from me this year. I'll tell you this right now. I took some time on that.
Would this be dependent because, actually no, because one answer is not going to affect the other? Or is it because the order matters? So would it technically be dependent?
It is not dependent, but I'm trying to think of a good way to explain it to you.
No, I think I know what you're gonna try and explain. Like, I understand. I just wanted to make sure that, like, because if I spin a red and then I spin a green and then I spin a 4, that's not a possible comment. That's not the right thing it's asking.
So the dependent and independent takes into account the order kind of within the formula, where when you multiply out the probabilities, that's how it takes into account the order, I guess. What would make it dependent is the act that you are doing if each answer would be changed because of what happened the first time.
So, like, if I spun a red and then took out red,
Correct.
that'd be, okay.
That'd be dependent if that happened. Probability is absolutely the one topic that I see some students just get. Like, they totally understand all of it.
What?
And some people don't get it because it's not very concrete, like when we do formulas with algebra things, right? So like finding the 2 roots using quadratic formula, you do the same thing each time, and so there's a set way to find an answer. Whereas this kind of feels like it's open to interpretation. And some people are just really good at that, and some people aren't. And so trying to present this to you in a way where you can take it a logical order is what's hard to teach. No, Diego, I feel like I called on you last week. Why don't you pick somebody for me? So Morgan, who's feeling better, I think. Are you feeling better yet? Okay, good. Then you can answer. Oh, too late. So all I was going to have you answer, even though I sort of already answered it, are these independent or dependent? Okay, you definitely didn't hear me answer it then. They are independent because each time you spin it, it won't affect the probabilities of the next spin. Basically, everything is just kind of reset each time. Thank you. If you spun the spinner and then removed certain answers, then that would affect the next spin, and so that would be dependent for this situation. Okay, so that means we need to multiply each individual probability to find the answer. Okay, Morgan, is there somebody you want to call on? Yeah. No. Oh, okay, good. I was going to say, let me rephrase that. Well, that was just cruel. But very fair, to be honest, very fair. I was expecting Diego to pick somebody farther away. Okay, Diego. I like this, because then you can blame her and not me. What's the probability of us spinning a red one? 2 out of 8, because red is 2 of the pieces, and there are 8 pieces. Do you want to keep going, or do you want somebody else to go? Oh, okay. Yes. Wait, you kind of already chose. This kind of screws up our rules. Drew, you never got to choose. Pick somebody. After all that.
I'll go.
What?
I did it.
All right. What's the probability of green?
3 over, probability of green. 3 over 8.
Yep, 3 over 8. There's 4 of them. You absolutely can reduce the fraction immediately if you want. So like if you wrote this as 1/4 times 3/8 times 1/2, absolutely you can do that. That's probably the easiest way to do it in your head. I'm sure some of you immediately went to a calculator. There's nothing wrong with that either. I mean, I certainly feel like I could make fun of you for that, but I won't, because I'm better than that. For these
We can
three,
make fun of you.
for these 3 seconds, I'll be better than that. So 1/4, 3/8, 1/2 would give me 3/64. Now, you can have the answer as a decimal, so even if you went to the calculator, that'd be okay. Do you guys know how to reduce a fraction on your own individual calculators?
Yeah.
Okay? So if you are using Desmos and you use the fraction button, which I think says like A over B, then I believe it automatically reduces your final answer and writes it as a fraction. I believe. If you are using a graphing calculator and you get a decimal answer, there's a button on the left-hand side that says Math. And when you click that, the first choice is some kind of weird arrow frac. You choose that by hitting enter, and then hit enter again, and it'll make your answer a fraction. If you have a scientific calculator, each one of them has a little bit different mode to entering fractions. I feel like most of the scientific calculators have a button that looks like this. I can't remember the exact notation. It might even show, is there one that says, some of you have a button that says F and then D. And that's how to convert, that's how to change your answer between fraction and decimal. So if your answer is shown as a decimal, you hit this button and it changes it to a fraction. If your answer is a fraction and you hit it, it'll change it to an answer. Each calculator is a little bit different. I can help you with your own individual calculators if you want. But it didn't have to be a fraction. I just thought I'd bring that up and show that. Okay, what time did we get done?
44.
Oh, why am I so early? I feel like I'm done early. That's what the beginning of tomorrow is going to be. What did I skip? I wasn't planning on being done because the section's decently long overall. And I didn't want to give the homework until the end of the whole section because the homework is kind of mixed together. And so you need to know independent and dependent beforehand. Today was mainly going to be independent, even though like I offered it as a choice each time. All the questions we did today were independent. Tomorrow is going to be all dependent.
If it was dependent, I might be getting ahead of myself, but if it were dependent, would I just like subtract it? Like, if it were,
Kind of. You're getting ahead of yourself. It's different for every situation.
Okay.
So it's not something I can just give you
yeah.
I started teaching this problem in my second hour, and then I wasn't very satisfied with my explanation for it without a picture.
Oh,
And so I decided just to do all the dependent tomorrow so I could have a better explanation. So I'll stop here. What I can do is I can go hand back your tests. And then that'll give us some time to go over the different things. I'm sure there's some people in here who haven't taken it yet. Yeah. Why don't you